This video will concern itself with another aspect of select statements, that of subqueries. You are allowed to have SQL queries inside of SQL queries. They're not used as often as the more traditional ones, the ones I've already showed you, but often they're the only way to solve particularly challenging problems. Before we get into that, I just want to mention a particular database that we'll be using a lot in the homeworks, the HackerRank homeworks. That's the Chinook database. It looks like this. I'll walk you through what these different parts mean. It's basically a relatively large table with a lot of rows that represents both kind of a combination of an iTunes style library as well as a employee and customer database. And so for many of the HackerRank questions, we'll be using this database to do more complicated queries that involve joining things from multiple tables and doing more interesting queries on more real-world data. To walk through kind of the layout of this, the way that it works is this is a particular table named track, and here are all of the columns within that track. So there's track ID, name, and so forth. The little key here represents the primary key for this table, which means that this row must be unique and not null. This key is basically used to connect this table with other tables. For instance, we'll start here with this artist table. It has an artist ID. Every artist has an artist ID, and each artist also has a name. Multiple artists could have the same name, in which case they would be distinguished by their artist ID. However, each artist can be connected to this album table because every album has an artist that worked on it. So you can always look in the album table, get the title of the album, and then look at the artist ID to figure out which artist created that album. Tracks can be part of albums. Tracks can also be part of playlists. Tracks can be in a playlist that has a particular name, and there's genre, media type, and so forth. So you don't have to memorize this. It'll be linked to from all of the homeworks. And it's just more for if you guys want to see the bigger picture, if you guys want to play around with the database on your own to do your own practice with. Okay, so on to the actual content of this video. The first type of subquery I want to talk about is called a union. So you guys have done unions in logic. A union combines the result sets combines the things returned by two separate queries. In order for a union to work, the two different queries must have the same column data type. So if you're trying to do a union of first name and last name from students and first name and last name from employees, both of those data types must be of type text. You can't combine strings with numbers and so forth. So you have to have all the columns in the same order with the same types for the queries that you return. The other thing to note is the names of the columns of the two queries that are being combined don't matter. All that matters is that they're in the same position. This really won't matter because almost all of the unions we're going to be doing are among tables that are very similar with each other. So a nice example is, let's say, using the same Chinook database that I just showed you before, I want the names of all of the artists and the albums all in one result set, all in one return. So the way they do that is, well, how do you select all the names of the artists? You say select artist.name from artist. How do you select all the albums? Well, you say select album.title from album. And how do you combine them? You stick a union between the two of them. This is one select statement that's combining kind of these two sub-select statements together. All right, so that's union. There's another variant called union all. So by default, the way union works is it performs what's called a distinct. We'll talk about this in a little bit on the result set, which basically removes any duplicate rows. So if you had an artist that had the name Prince and you had an album that had the name Prince, it would actually only stick one row in the previous example. However, union all doesn't remove duplicates. And so you can have Prince would appear twice if there's both an album with that name and an artist with that name. And because of that, it's actually faster to perform than union, because performing a removing duplicates actually takes time. So if you need to write queries that need to return quickly, union all is sometimes faster, but usually that doesn't really matter much. So an example is, let's say I want all the artist and album names, but I want to allow duplicates. If an artist and album have the same name, they both should appear in the result set. You just stick a little all after the union. And that's basically it for how union combines the results for select statement. Now with union, we can actually solve a problem that we had last week of the fact that SQLite and actually a lot of database management software like MySQL and stuff don't provide a full outer join. So once again, what is a full outer join? A full outer join is basically join two tables and give all of the rows that have matches, those are rows returned by an inner join, as well as the rows that don't have matches, like those performed by a left outer join and a right outer join. So if I want all of the albums and artist pairs with nulls where they don't match, but I don't care about when an artist and an album actually match together, well, I would say select artist.name and album.title from artist, and I'm just doing a left outer join on album with artist.artist.id and album.artist.id. So what this is saying is get all of the artists that have albums and all of the artists which don't have any albums. And then I say union all because I want to combine this with another query which looks very similar to the previous one, except I swapped the album and artist in the join. So now I'm also combining a left outer join with album on the left and artist on the right, whereas here artist was on the left and album was on the right. So I'm combining the other side. Now the problem with this is some rows are going to be duplicated. Left outer join includes the places where they matched. And this left outer join also includes the places where they matched. So the way to get rid of this is I'm adding a little where clause on this second select statement, this select statement right here, that says, hey, by the way, for this join, exclude any times when the artist ID is null. Exclude all of the albums that you, all of the artists which didn't have a match. All right, so first multiple choice question. All right, so can you write a full outer join now? Maybe. In reality, you won't really ever really need to write that. You usually would be writing, the reason why full outer joins aren't provided by default is because they very rarely are needed. Usually you need the inner join or the left outer join or the left outer join excluding the inner, but needing a full outer join is pretty rare and probably should be broken up into two queries. So if you didn't follow the previous slide, don't worry about it. If you have questions understanding, you're welcome to ask questions on Pialta. I'll never ask you to write a query that difficult or that hard. All right, next multiple choice question then. When is a left outer join the same thing as an inner join? So the correct answer here is actually 2. So a left outer join includes the inner join as well as all of the rows that were in the left side that didn't have a match with the right table. So if there aren't any places where there are missing left rows, where left rows can't find a match, then a left outer join is the same thing as an inner join. So one way that might help with visualizing all of these different joins, left, right, inner, outer, there is this nice little Venn diagram description, but hopefully this is starting to make sense. Inner joins are the rows where you're able to match the left and the right side. The left outer portion and the right outer portion are the parts that didn't have a particular match, and hence, if they're included, they have nulls for filling in the column parameters for the other side. So let's talk a little bit more about subqueries. So we talked about union, and union kind of has subqueries. You have multiple select statements together, but actually subqueries is often used to be a more specific term, where you say a subquery is actually a SQL query within another query. So the nice thing about subqueries that makes them actually slightly more powerful than the unions we talked about before is that the nested queries can actually give information to the outer queries coming out. So subqueries can return individual values or mini records as well. And the rule for subqueries is you must have them separate, enclosed in parentheses, or else they may not be parsed correctly. So let's think of an example where we need to use subqueries. If I wanted to get all of the artists who released an album that was the same as their own name, so the album's title is the same thing as the artist's name, how would I write that? I say, well, I want to select the artist name, that's the information I want, from artist, where artist name, and now I need to write a subquery that gives me all of the album's titles. Because if I had like a list of all of the album's titles, I could just say where artist name in that list. But how do I generate that list? Well, I make a little subquery that gives me the list of all of the titles. So I'm basically saying for each row, check if that particular artist name is in this set, is in the set of album titles. So the in is a common keyword preceding a subquery if you need to look for inclusion. Another sort of subquery is that of exists. So a where exists clause basically says, is there any record returned by a subquery? One or more records. So the exists returns true if a subquery gives you one or more. And exists really is only used with correlated subqueries. These are nested subqueries that use values defined in the outer query. This will make a little bit more sense with this example. So let's say I want to find all of the tracks that appear in a given playlist. So how would I do that? Well, I want to select the track's name that appears in a playlist from tracks, and I say where exists, and my rule is I want to include the track if it's in a playlist. So how do I do that? Well, I can write a subquery that says, hey, find me all of the tracks that are in playlists from playlist track, and I need to find out if this track ID, the track ID right here, if this track ID is in the playlist track. So if the track ID in the track table is in the playlist track table, they match by track ID, that means, hey, this track that I'm looking at is somewhere in that other table. Now, I don't care if that track is in multiple playlists. I only care if it's in one or more. So this select statement will either return 0 rows or more than 0 rows. And if it returns more than 0 rows, this exists will be true, and I'll spit out the track name. If it returns 0 rows, this is false. This where clause fails. I don't include that particular row. So, index card question. Does the columns returned by an exists subquery, that would be this subquery right here, like this select playlist track, does the columns that are returned matter? So the answer here is it's a little bit tricky, but really it's no. It doesn't matter what columns returned, because all that matters is, are there any rows returned or are there no rows returned? So if you return many columns, one column, whatever, doesn't actually matter. So in fact, all of these queries are the same. If I say select star from track, or if I say select star, and here I was returning the specific playlist track.track ID, I could just say, hey, return all of the columns from this subquery. Or I could even be simpler and make it really obvious. I can say select the number 1 from playlist track to basically say, if you find something, return a 1. So once again, the columns actually returned by an exists don't actually matter, because all I care about is how many of them were returned.